Good morning all. I am Dr. Gayathri NS, working as Assistant Professor of Chemistry in SNS College of Engineering. Today I am going to share about nanochemistry in engineering chemistry syllabus. Nanochemistry is a branch of nanoscience, deals with the chemical applications of nanomaterials in nanotechnology. The nanotechnology, which involves the study of synthesis and characterization of materials of nano size scale. Nanochemistry is relatively a new branch of chemistry which is more concerned with unique properties with assemblies of atoms or molecules of nano scale, that is 1 to 100 nanometer. These are the particle size and their surface, that is 1 millimeter, 1 μm and 1 nanometer. The surface, while moved to the nano size, the surface area is completely in large scale. That's why nanoparticles are better than bulk materials. There are physical and chemical properties in manipulating atoms to form molecules and nanoscale assemblies. There are so many physical techniques which allows atom to be manipulated and positioned to specific requirements for prescribed use. The traditional chemical techniques arrange atoms in molecules using well characterized chemical reactions. Nanochemistry is the science of tools, technologies and methods for novel chemical synthesis. For example, employing a synthetic chemistry to make nanoscale building blocks of desired shape or size and composition, also surface area, which is possibly very potential to control the actual self-assembly for these building blocks to variable sizes. The nanoparticles have a high surface area while comparing to the bulk particles, which has dramatic effect on their properties when compared to non-nanoscale forms of the same material too. Nanoparticles, the size of which ranges from 1 to 50 nanometer. Generally, they are obtained as colloids. The colloidal particles which have a tendency to remain a single crystal, and it is also called as nanocrystal. The nanoparticles 1 to 100 nanometer and the saucer ball 0.1 meter and the earth 0.7 meter. Nanochemistry, the nano crystals which possess electronic, magnetic and optical properties. The nanoparticles exhibit electronic behavior which is governed by quantum physics, therefore it is called as quantum dots. For example, iron oxide, here we are seeing a 20 nanometer and 20 nanometer size of the materials. Nanomaterials, the material which having components with size less than 100 nanometer, at least in one dimension, and the nanomaterials in one dimension are layers such as thin film or surface coatings. The nanomaterials in two dimension are tubes such as nanotube or nanowire, and the nanomaterial in three dimension are particles like precipitate, colloids and quantum dots. Next, we move on to the classification of nanomaterials. The nanomaterials are classified according to their dimensions, that is 1D, 2D, 3D. The 1D is less than 100 nanometer. All these dimensions are less than 100 nanometer only. For one dimension, we have seen that is a film material, layers and coatings. And the nanowire, nanotube fibers are the 2D. And quantum dots, nano rings, microcapsules are the three-dimensional one. Properties or characteristics of nanomaterials. The nanomaterials possess a very good electrical properties and thermal conductivity. It also possesses very strong and withstand extreme strain and tension. The physicochemical properties of the nanomaterials are size, shape, composition, surface volume ratio, aggregation, stability, surface chemistry, surface charge, negligible properties, etc. The main nanomedicine applications are gene chemistry, gene delivery, diagnosis, monitoring, drug delivery for therapeutic use, tissue engineering, detection, imaging, drug screening, labeling are the main uses in the nanomedicine. The renewable energy, biomedical and healthcare, construction materials, even though electronic and energy storage materials, environmental remediation, food packaging, processing, and agriculture.